Critical Risk Assessment CAR003 Special Status Full Spectrum Independent Resource Allocation. Three Gorges Dam Full Spectrum Prometheus Platform Risk Assessment. Rotational Mass Imbalance, Schumann Phase Correction, Reservoir-Induced Seismicity Dam Failure Hydraulic ELE, Bore Route Planning, Crustal Stress Field Perturbation. Master Verdict CAR003. 1. The Three Gorges Dam, Planetary Scale Physical Parameters. Before assessing risks, the shear scale of the Three Gorges Dam must be established numerically. This is not an ordinary dam. It is a planetary scale mass redistribution event whose effects on Earth's rotational dynamics, crustal stress, and regional seismicity are measurable from orbit. 2. Angle 1, Rotational Mass Imbalance and Schumann Phase Correction. 2.1 The rotational imbalance problem. The Sealy analogy of a rock in a tire is physically precise. When a tire is out of balance, the rotating mass creates a periodic forcing function at the rotational frequency. For Earth, the Three Gorges Reservoir represents a persistent off-axis mass concentration at 30.8 degrees north, 111.0 degrees east, not at the equator where it would have maximum rotational effect, but close enough to produce measurable consequences. The 0.06 microsecond rotational slowdown is the integrated effect of moving approximately 39 trillion tons from distributed ocean surface to a concentrated inland reservoir at 175 meters elevation. This increased Earth's moment of inertia slightly, like a spinning skater extending their arms, slowing rotation by conservation of angular momentum. The 2 cm polar shift is more operationally significant for Prometheus than the rotational slowdown. The QLAG quantum positioning system operates at nanometer accuracy. Its reference frame is tied to Earth's figure axis. A 2 cm shift in the figure axis that is not accounted for in the QLAG coordinate mesh produces a systematic position error that accumulates with distance from the reference meridian. QLAG position error from uncompensated polar shift, 2 cm polar shift at 111 degrees east longitude maximum position error at 90 degrees from shift azimuth, approximately 2 cm error at East Asian bore routes, less than 0.5 cm error at European bore routes, approximately 1.5 to 2.0 cm QLAG nanometer spec requires correction. Correction is a coordinate offset, straightforward software update. 2.2 Schumann resonance modal frequency perturbation. The Schumann resonance frequency is determined by the circumference of the Earth ionosphere cavity and the cavity's effective height. The Three Gorges Dam perturbs this in 2 ways. Ionospheric coupling. The reservoir surface area creates a persistent anomaly in the local atmospheric electric circuit. The reservoir acts as a large flat conductor at near ground potential, modifying the fair weather return current density in the column above it. This locally perturbs the ionospheric potential by a small but measurable amount, shifting the effective cavity height above the reservoir region by an estimated 50 to 200 meters. RIS electromagnetic noise. Reservoir-induced seismicity produces seismoelectric signals, electromagnetic transients associated with microfracture events in the loaded crust. These appear as broadband noise in the SR monitoring frequency range and are correlated with RIS event catalogs. For Prometheus Layer 4 operation, both effects require a Three Gorges regional correction factor, a defined geographic zone within which SR modal frequencies are offset by plus 0.02 to plus 0.05 Hz from the global baseline, and within which elevated seismoelectric noise must be filtered from SR monitoring data. Layer 4 Correction Protocol TGL4CP01. Within the Three Gorges correction zone, apply SR modal frequency offset of plus 0.03 Hz plus or minus 0.02 Hz to layer 4 emitter targeting frequencies. Filter RIS seismoelectric noise from SR monitoring data using cross-correlation with CENC real-time seismicity catalog. Apply 2 cm polar shift coordinate correction to QLAG reference frame for all bore routes within 5,000 km of the dam. Prometheus Layer 4 Schumann emitter arrays within the TG-RIS zone are assigned enhanced operational priority. The emitter array serves a dual function: primary seismic attenuation per PHRPC 1.0, and as a passive RIS monitoring network by cross-correlating emitter coupling impedance variations with the CENC seismicity catalog. Anomalous impedance variations in the emitter array that precede cataloged M greater than 3.0 events by 30 to 120 minutes are logged and reported to the Quench Watch system. This gives Prometheus infrastructure an earthquake early warning capability as a byproduct of normal Layer 4 operation. 4. Angle 3, dam failure as a civilizational scale hydraulic ELE. 4.1 failure. Failure mode analysis. 3 Gorges dam failure scenarios and their relevance to Prometheus infrastructure planning. 4.2 The inundation corridor, what cannot be hardened. The 3 Gorges downstream inundation corridor follows the Yangtze River from the dam at Yichang to the Yangtze Delta at Shanghai, approximately 1,800 kilometers of river valley. The inundation width varies from 5 to 10 kilometers in the gorge sections to 30 to 80 kilometers across the Zhonghan Plain and Poyang Lake Basin. No bore infrastructure within this corridor at depths less than approximately 500 meters can be considered protected against the hydraulic shock of a major dam failure. The flood wave arrives as a wall of water 30 to 150 meters high, traveling at 20 to 40 kilometers per hour. The resulting hydrostatic and hydrodynamic pressure transient propagates into the ground and would destroy any surface portal, shallow bore section, or unprotected infrastructure within the inundation envelope. Below approximately 300 to 500 meters depth, the bore structure itself would survive. The rock overburden provides adequate hydraulic shielding. But surface portals in the corridor would be destroyed or rendered inaccessible for months. This makes the corridor unsuitable for any Prometheus infrastructure requiring surface access. 5. Angle 4, bore route planning around the 3 Gorges constraint. 5.1 The routing problem. The 3 Gorges Dam sits astride the most direct bore path between several major Prometheus intercontinental route pairs. The constraint has 2 components: the RIS seismic zone and the downstream inundation corridor. 5.23 Route options evaluated. Route A, Northern Bypass. Bore path deflects north of the 3 Gorges RIS zone, routing through the North China Plain at depths of 15 to 25 kilometers beneath the Ordos Plateau and Shaanxi Graben. Avoids the RIS zone entirely. Surface portals in the Yellow River Basin, not in the Yangtze inundation corridor. Route addition, approximately plus 400 kilometers versus direct line. Geologically, Precambrian basement at depth, excellent boring conditions. Verdict, preferred route for Europe East Asia primary bore. Route B, Southern Bypass. Bore path deflects south through Yunnan and Guizhou provinces, routing at 20 to 30 kilometers depth beneath the Yunnan-Guizhou Plateau. Avoids the RIS zone. Surface portals in Kunming or Chengdu Basin area, upriver of the dam, not in the inundation corridor. Route addition, approximately plus 600 kilometers versus direct line. Geologically, more complex, multiple thrust fault systems in the Tibetan Plateau margin. Higher boring difficulty. Verdict, secondary route or regional spur. Route C, deep direct transit. Bore path takes the direct Great Circle route but at extreme depth below the seismogenic zone entirely, within the lower crust, upper mantle. At this depth, reservoir loading effects are negligible and no surface portal is required in the inundation corridor. Route addition, approximately 0 kilometers. Depth addition, significant. Prometheus plasma cutting at mantle depth, feasible by design. Thermal management, requires active bore cooling, rock temperature at 50 km depth approximately 800 to 1000 degrees Celsius. Verdict, long-term option, Phase 3 technology. Not Phase 1. 7. The bigger picture, what Three Gorges tells us about Prometheus. The Three Gorges Dam analysis reveals something important about the Prometheus platform that goes beyond the specific risk assessment. Human infrastructure at planetary scale creates permanent geophysical perturbations that must be accounted for in any global engineering system. The dam is one of several such perturbations that the Prometheus Layer 4 calibration and QLAG coordinate system must carry as permanent correction terms. Others include groundwater depletion, massive aquifer depletion in the North China Plain, the Ogallala Aquifer, and the Indus Basin has shifted polar position by an estimated 4.4 centimeters since 1993. This dwarfs the Three Gorges effect and must be modeled as a time-varying QLAG correction. Ice sheet mass loss. Greenland and Antarctic ice loss produces ongoing polar drift of approximately 10 centimeters per year toward 75 degrees west. This is the dominant source of polar wander for QLAG reference frame management. Post-glacial rebound. Scandinavia and northern Canada are still rising at 5 to 10 millimeters per year from the last glaciation. Bore routes through these regions experience slow but continuous ground uplift that must be accounted for in long-term bore alignment maintenance. The Prometheus QLAG coordinate system must therefore be treated as a living reference frame, updated continuously from satellite geodesy and cross-validated against the QSGN quantum positioning network. Three Gorges is simply the most visually dramatic example of a class of corrections that must be maintained throughout the Prometheus operational life. Recommendation: Prometheus Geodetic Correction Registry. Establish a Prometheus Geodetic Correction Registry as a permanent operational database maintaining time-varying correction factors for Three Gorges polar shift and SR modal offset, global groundwater depletion polar drift, ice sheet mass loss polar wander, post-glacial rebound by region. PGCR is updated quarterly from GRACE-FO and IERS data and pushed to all QLAG reference nodes. This is a software and data operations function, no hardware requirement. Formal sign-off CAR003, Three Gorges Dam. I, Chris D. Seeley, inventor and chief engineer of the Prometheus platform, confirm that this critical risk assessment has been reviewed and that Route A is adopted as the primary bore route for the Europe-East Asia Intercontinental Corridor. No surface portals will be located within the Three Gorges downstream inundation corridor. The Three Gorges Regional Correction Factor is approved for implementation in the Prometheus Layer 4 control software and QLAG coordinate mesh. Enhanced bore structural specification is approved for all bore sections within 200 kilometers of the Three Gorges Dam. The Prometheus Geodetic Correction Registry is approved as a permanent operational database to be established at Project Phase 1 and maintained throughout operational life. CAR003 is signed off as a resolved risk with the route decision and technical mitigations defined herein. Risk CAR05 is closed by Route A adoption. All other risks closed by engineering specification and software correction.